this is Shima, also of GHL. You're a member of BOABC? Yes. Okay, so this is a hard presentation to put together because there's all these ideas out there about continuity of fire separations. And I actually didn't even get all the answers to all the questions I had. But we'll do our best. Not this. I took that photo myself. It's quite scary. I'm just going to click the. So just copyright, blah, blah, blah. That's where our office is, Granville and Hastings, downtown. Been around since 1992, focusing on mostly Part 3. We don't get a lot into Part 9. You guys everybody can manage that sort of without us, mostly. We do fire hazard analysis, fire risk, evacuation, smoke control stuff, accessibility, quite a bit of like expert witness type of work in slips and falls and those things. And then Andrew, who's in the next room talking about 12-story wood timber buildings, I think, he's on all these committees, madly writing code and changing the world and CLT high rises and firewalls and everything. So we hardly ever see him anymore. Okay, that's probably enough about us. So I'm just going to start out with the very, very basic stuff. And some of this stuff you've seen it a million times, but just sort of the concept of what's a fire compartment, what's a fire separation. But then what I really want to do is get into discussion about closing the holes, because that's where everybody gets all hung up. So a fire compartment is basically a box, and that's the fire starts up there, and the heat rises, and then it starts radiating, back on itself as the surfaces get hot, and eventually everything goes at once. So the objective in the building code and sort of in practical terms is to limit the fire, to contain the fire, limit its spread to other spaces. So firstly, ideally to the object where it originated, so the sprinklers would primarily do that. Then to the room where it originated, and again, if you have sprinklers, but also the fire separations, then into the story that it originated in, so it doesn't spread to other stories, so that's fire separations, and then to that building and not to the neighboring buildings, and that's your spatial separation. During the time required to achieve occupant safety and for emergency responders to perform their duties. Not forever, but for kind of a defined period of time. So the definition from the National Building Code's Ancient User's Guide says that the primary function of a fire separation is to act as a barrier against the spread of fire. So that's a physical barrier against the spread of fire, whether it's rated or unrated, doesn't matter. Sometimes people say, oh, can't we put a water curtain there? It's like, well, not really. We still need a physical barrier against the spread of fire. And water reduces radiation, but it doesn't make a physical barrier against fire spread in terms of an interior fire separation. And the fire compartment in the building code is defined as being bounded by fire separations that have a fire resistance rating. So if you have a fire separation that's unrated, that splits a space, say an office to a corridor or whatever, technically that's the same fire compartment, which is going to come up later. It's important. So fire burns up, and our goal is to keep it in the space where it started. And there's a bunch of objectives. Oh, that's fine, Jim. So this is an interesting thing that we talked about actually in the office the other day, and that is, why are some fire separations 1 hour or 2 hours? And the requirement for the higher fire resistance rating is not because the fire is bigger or lasts longer in a larger or higher building. It's what Andrew called a ham-fisted method of getting a more reliable fire separation. So a 2-hour fire separation is more reliable than a 1-hour fire separation, but you're probably dealing with the same fire, unless you're in, an F1 or some crazy occupancy with a really high fire load. I always have this slide since the beginning of time, because everyone's always saying you should think outside the box, and when we're thinking about fire separations, we should think inside the box. I think we kind of said this, the places where the code prescribes fire separations, like between stories, between differing occupancies, where one might have a higher fire load and the other one has a higher occupant load. The building code always wants the same fire resistance rating from both sides, but in reality, if you had a retail beside an assembly, the hazard is from the retail to the assembly. It's not so much in the other direction. Oh, and then in suites, between suites that are occupied by different tenants or under the control of different persons, in some specific rooms that might pose a little hazard in the building, and then, of course, the structural fire resistance for the floors and things. So the weak points are the joints where they abut each other, the joints around pipes and wires, and at openings that are protected by doors and dampers and things. And there's a bunch of ways to determine a fire separation or fire resistance rating. So Part 3 lets you use these specific assemblies that are in the table in Part 9, the R1 and M1 and M2. Appendix D has a bunch of generic designs that you can make by adding things together. The ULC listings, they have proprietary designs where you have to follow them to the letter, but they also have generic designs where you could use any kind of, that don't specifically say you must use this kind of gypsum board and you must use truss joists and you must do this. You can use type X or type C in the generic designs, but in a proprietary design that was tested with type C, you have to use type C, because type C gypsum board is type X, but it's denser than type X, so it has better fire resistance. So if they tested it with type C, you can't replace it with type X. And if they tested it with type X, then type C is type X, so that's okay. So Appendix D was created by Mr. Harmathy, who also created the 10 rules of fire resistance, which are quite interesting. So he invented the method, the component additive method for adding up the layers and the concrete slab column walls and the minimum cover in the rebar. And there's been some changes to the Appendix D. There's a lot of blue in there in the 2018, and some of it's pretty interesting. There's more options for assemblies now in Appendix D. There's an option for double 5/8 on wood joist. Thank God. Can you back up a sec? There's more discussion on permitting openings in the membrane-only ceiling. There's discussion on pipes and wires, or on permitting pipes and wires in there. And there's a factor you can add now for a concrete topping, because that has some benefit in terms of thermal temperature rise on the unexposed side. So, and the Appendix D stuff, of course, comes out of the National Building Code, and the BC Building Code has a different method for this membrane sealing thing in 31714. So those tables in Part 9, when they expanded them, it was based on a whole series of fire tests at NBC, or Codes Canada now. And they tested a bunch of things, and then they interpolated those results to come up with a whole bunch of other fire separations. So like every fire separation in the building code isn't tested. Some of them are just sort of made up based on what they knew about tests in other things. But the tables in Part 9 and the component additive method in Appendix D are not based on the same on the same assumptions or on the same method. So you couldn't say, okay, I'm going to use this table, this one out of the table, and then I'm going to add a layer from Appendix D, and that's going to give me another 40 minutes or something. So you can't really mix and match those things that way. And then there's the fire testing, which we'll just zip through. There's 3 failure criteria: structural failure, temperature rise on the unexposed side, and flame going through the floor, of course. And there's a horizontal furnace for floors, which we don't see much because there isn't one here. There's one in Washington State somewhere. And then there's vertical wall tests. There's a lab in Burnaby, there's a lab in Coquitlam. You should really go see one, they're pretty fascinating. And then there's the S134 for the flame spread on the outside of the exterior wall, and there's the S115 for the fire stops. So the fire test is it's a model. It's not, I mean, it's a real fire. They build a wall and they put it in a furnace and they light it on fire, but it's not a real fire in terms of how a fire would behave inside a room or a building. So it's like a model, and it's been around for 100 years. And if you look up fire testing in Japan and fire testing in Australia and fire testing in the UK, they're all exactly the same. There's one fire test in the world. We call it S101, they all call it something else, but basically there's one test. So they build this wall and they put the thermocouples on the outside of it, and then they push it up into the furnace and light her up, and that's what it looks like afterwards. And then this is a steel. This is in here because you can see the difference between the steel and the wood, that the steel buckled quite significantly. And then I think we just have a couple of pictures of that's a floor furnace, and the thing on the top is how they load it. And then they build the floor up against it, and then they burn it. Okay, and so I mean, like I said, it doesn't really compare to a real fire. So a few years ago, I don't know when exactly, can't remember, Codes Canada did some real fire tests, and they mocked up I can't remember if they were 2 stories or 3 stories, but they were like apartments, and they tested light wood frame covered with gypsum board, light steel frame covered with gypsum board, and the mass timber protected with gypsum board. And it's 3 stories. So they built this, and then they finished it and filled it with furniture, like an apartment, like this. And then they lit it and stood around in the lab and watched it burn and saw what it did and figured out a bunch of stuff and wrote a report about this big. But the interesting thing about the report is the report says that the objective of the study was to determine whether encapsulated or gypsum board protected wood framing could be used as an alternative solution to non-combustible, where the code prescribes non-combustible. And the 2 important conclusions in Chapter 9 of that report say that the wood framing performed as well as the steel, and that the wood framing met the intent statements attributed to non-combustible construction, or to the requirement for non-combustible construction. So basically, Codes Canada told us how to do an alternative solution to use like protected wood in lieu of non-combustible. And those words, as well as, I mean, they knew it, obviously, they had a plan in mind in terms of alternative solutions, because when they said it performs as well as, that's exactly what the building code says the target is when you're looking at an alternative solution. So, when we create this box, it's either vertically continuous, meaning the vertical fire separation continues through the concealed space in the floor or the roof, or it's horizontally continuous, meaning the fire separation abuts up to a horizontal fire separation, and then you've got all these boxes, basically. So this sentence 31831 says a vertical fire separation has to continue through the horizontal space. And we typically use some kind of fire blocking to maintain the fire separation through the floor or the roof. So historically, the information on sawn lumber said that you get 0.6 millimeters per minute of char, and therefore a 38 millimeter fire block, basically a 2x10 or whatever, is somewhere around an hour. And we'll explain how that works in a minute. So, and we might need a gap in the wall for sound transmission. Like we're not talking about sound transmission, and maybe you'll look at our drawings and say, oh my God, that doesn't work for sound, but we're not talking about sound, we're only talking about fire. But typically we get this gap up inside the wall for sound, and you can close the gap somewhere with wood or comfort board or the steel fire stop thing, or the code says you can leave a 25 millimeter gap. So between two insulated studs, right? So the gap has all been tested, and a 13 millimeter gap will limit fire spread for 30 minutes, and a 25 millimeter gap for 15 minutes, and a wider gap for a shorter time, obviously. So obviously the code picked the 25 millimeters for the 15 minutes because it says a fire block has to be 15 minutes, and if this gap works for 15 minutes, then it's the same thing. So the vertically continuous fire separation in this double stud wall, which is typically the rim boards are typically load bearing. Oh, go back. So sometimes you use this method. Some walls, some proprietary like truss joist details say to put gypsum board along the rim board. And so in the diagram on the left, the gypsum board is the fire block, and the rim board is the structural member. And this is for when you have an unrated ceiling. So, and even in the unrated ceiling scenario, the fire that starts in the room, it has to penetrate the ceiling first, and then get sort of at that fire block. So people always say, oh, you can't count the ceiling. But I mean, if you have gypsum board on the ceiling, you've got some fire resistance in the ceiling. So the one on the gypsum board is the fire block, and the rim board is the structural member. And then on the next one, this is more like what you see more often, where the second lumber piece of member is the fire block, and then the inner one is the actual structural member. So there's this American book where they did a bunch of testing on rim boards, and they tested a single LVL, or they tested engineered rim board, like an LVL by itself, or a 2-ply, or one with gypsum board and one without, and I think they got, in the load-bearing scenario where they didn't have the second rim board, they got 43 minutes out of the single rim board, and it probably because it failed structurally. And then in a non-load-bearing wall, you don't have to add all that double extra fire blocking, because the rim boards are just the fire blocking. They're not structural members. They're just making that fire block or maintaining that fire separation vertically. Okay, and so this is why the fire blocking thing works differently than when we're talking about joists. Because a joist, in the event that the gypsum board fails, is exposed at 3 sides simultaneously. And What does Appendix D says you get 10 minutes out of it. If it's oriented like a fire block, then it's sandwiched between the plates and the above and below, and it's only exposed to fire at that one face. So it behaves differently. It lasts longer. And then the other thing that's kind of interesting is we spend all this time thinking about these fire blocks and adding up these numbers and everything and making sure the fire is not going to go vertically like through the floor like that. But I mean, it's a floor with a bunch of 10-minute joists. So the floor falls down or fails, then I mean the fire's not going to sit there knocking on that rim board for an hour. It's just going. It's going to take the path of least resistance. And Harmathy's rule number 1 is that a series of parallel, the fire endurance of a series of parallel members is much higher than if you just tested them individually and added them up. Okay, and so in this, when we're doing this vertically continuous thing, there's these ideas out there that, firstly, that you can't consider the ceiling, which, or I hear often, well, what if the fire starts inside the floor? Or what if the fire starts inside the wall? And I don't believe that that's the fire scenario that the building code's trying to address. So I pulled out the information from NFPA on where fires typically start in a building, and it said 0.5% or 0.3% started in a wall or a floor or a roof space or something. The other 97% start in the room somewhere. So, I mean, I don't know why you couldn't. When I first started at the city of Nanaimo, we would look at this and say, okay, there's gypsum board on the ceiling, that has some rating, and then there's this block, and that has some rating. And then there's also this in 3111, on the section on fire blocking, it says anything that will stay in place under the fire test for 15 minutes can be used as a fire block. And then it says a 38 millimeter member can be used as a fire block. But we don't take those two things and add them together and say, oh, that means that a 2x10 has a 15-minute fire resistance rating as a fire block, because it's probably much higher than that. I know somebody said to me the other day in that scenario where you have the rim board and the rim board and the block, they're like, oh, that's an hour because it goes 15, 30, 45, 60. Well, it's like, well, that's not really how it's going to work in a fire. It's not going to burn through 4. And what's holding the thing up after the second one's gone? Nothing. And then the third one, again, that we're spending all this time thinking about how to maintain that fire separation through blocking through the floor when that's not actually the weak point. And the fire's not going to spend an hour banging against that when it can, because it's a fluid, it's going to go in the easiest possible direction. And then the other option, and this is a kind of a strange statement in the building code, is that if you don't continue the fire separation vertically through the floor, then the horizontal fire separation is described in this sentence in 3.6 as being between the concealed space and the occupied space. And that's how everybody gets all excited. It's a membrane-only ceiling. You can't count the joists. There's a whole bunch of discussion around that. So basically, the fire rating is the yellow. It goes across the ceiling, and the floor or the wall butts up to it. The other question that comes up all the time, if you go back, is, oh my God, those top plates can't interrupt now you have a hole in the horizontal fire separation that's made by the wall. It's like, well, the fire blocking your double top plate at the top of the wall is closing the hole in that wall the same way that, or in the floor, the same way that the vertical fire blocking closed the hole in the other direction. So there's a certain municipality that shall remain nameless, where they want everybody to put this gypsum board continuous on the ceiling before you frame the wall. It's like, well, what are you holding the floor up with while you board it before you put the wall up? The only place they actually do this is in modular, because they build the floor on the floor and then they crane it up on top of the walls, so it's completely clad. So these are some diagrams from the mid-rise wood frame construction handbook, and they're showing the weak points. They're showing the joint between the vertical gypsum board and the horizontal gypsum board. But you can see that the top plates are definitely closing the hole in the ceiling. And then the next one, it's just the same thing. They're just talking about the weak points being the joints. And then this is from the best practices guide on fire stops and fire blocks, and it's got a rated ceiling, and then of course the top plates are closing the hole in the ceiling. That's probably enough about that. Okay. And then there's this membrane-only ceiling thing. So a long time ago, there was a fire separation in Appendix D called D2312, and it said that you can consider 2 layers of 5/8 type X to be the fire separation, regardless of what it's attached to. And it's like what we always call the membrane-only ceiling, or the membrane-only fire separation. But you couldn't have any openings in it. So then somebody did an appeal, 1646, in June 2008, and they said, does the code really say that you can build a fire separation? And this is the fire separation that's required if you butt your verticals into it, because 3642 says it's not the whole assembly, it's only the piece between the floor space and the occupied space. And the appeal board said, yeah, it does actually say, but holy cow, that's really dumb, right? Like you have a ceiling and you can't have you can't have a light, and you can't have a duct, and you can't have a pipe or a wire. It's a little bit impractical. So this is a BC code item that differs from the national, and the province in November of 2008 added 2 sentences. They added the sentence in 31714 that said you could use those assemblies called M1 and M2 from the table in Part 9. And they said the table in Part 9 calls them assemblies, therefore they're assemblies. And they're subject to all the fire stopping, fire dampers, whatever, that any other assembly is subject to. And so Lyle Kunert wrote the change, and he sent it to 2 of us at GHL, and we reviewed it and talked about it endlessly, and added some stuff to make sure that it was clear that you could have, ducts and pipes and everything. And still, twice a week, somebody says to me, oh, but you can't have openings in that ceiling. And I was like, come on, guys. 2008 was 11 years ago. It's been in the code for 11 years. So these myths, there's 2 sort of myths that we talk about all the time with this ceiling, and that is, 1, that no openings are permitted, which is what the code change fixed in 2008. And the other one is sort of getting mixed up about what's a horizontal service space in sentence 36422. So that sentence says that you can butt your vertical fire separations up against this ceiling. But there's kind of an idea out there sort of floating around that if you have any pipes and wires in your floor space, then it's a horizontal service space. Now you have to use this ceiling, which, I mean, it's a horizontal service space either way. It doesn't make any difference. It's a horizontal service space by definition. But the difference between the sentence that says to do it vertically and the sentence that says to do it horizontally is only about that you've decided to either maintain your fire separation vertically or horizontally. And the one really important thing is that sentence 31913 says that if you put a pipe or a wire through that ceiling, you have to have an FT rated fire stop. I mean, there aren't a lot of instances where you'd have a pipe in the middle of the ceiling, except maybe in the bathroom. So it's because, I mean, they're always running inside the walls and going through the blocking in the top plate, but it is there, and it's there in the national, and it's there in the BC, and it's been there for a long time. Well, I guess it's been there since the 2012. Seems like a long time now. And then I get phone calls once a week from an architect who says something like, do I have to cut up a whole bunch of gypsum board and jam it between my truss joists against the rim board? I'm like, I don't know. Which of the 9 tested details that come with your truss joist package did you pick? It's like, we don't have to make it up. There's a whole bunch of tested details in this book. So, and they're based on, the load that the rim board's carrying, whether the ceiling is rated. And the one that we use, or the one that we hopefully use, is this detail that beefs up the thickness of the rim board. So this is a maintaining a vertical fire separation with an unrated ceiling, number 3, 1/2 inch gypsum, regular. And all you have to do is beef up that rim board to 1 3/4, and then that will maintain that vertical fire separation through the floor. But oh my God, we're constantly madly writing alternative solutions in the middle of construction because nobody knew this. They're like, but I only have 1 1/4 inch rim board. And it's like, oh good, well then you can hack up 1 million pieces of gypsum board and get them in there. Or, we do alternative solutions to pack it with mineral wool instead because it's easier. But yeah, it just seems like there's this sort of missing link in the design. They're just like, oh, we're going to use truss joists, and then the structural guy figures out, how big his rim board has to be, and nobody thinks about the fire separation. Because there are details in the truss joist book where you do put gypsum board on the rim board instead, although I don't know why anybody would want to do that. But it actually, I think what they mean is you cut a piece of gypsum board and you paste it against your rim board, and then you put the trusses up against it. But then when you try to do this sort of mid-construction, the structural guy goes, no, you can't put gypsum board behind my joist. I don't have enough bearing. So what you end up with is that's just a picture of, obviously, the floor and the rim board. But what you end up with is like this messy, hideous thing that somebody's doing during construction. And then the shape of the joist, you got to cut all these little stupid pieces and put them in. And then it's like, do we have to mud and tape it? Maybe we should just blast it with FS1 and be sure. It's like, oh my God, what a mess. And it happens like every day. Intersections. This is a very common question too. What do we do? When I say question, they typically come from architects. I'm not talking about building officials. they say, oh, what do I do with where the vertical fire separation abuts the exterior wall? Do I have to run it all the way through the wall to the back side of the sheathing? It's like, no, the code says you need a tight joint where one abuts the other, and that's the joint in the gypsum board. Fire is not going to breach that exterior wall and get outside and then turn 180 degrees and burn its way back into the fire compartment next door from the outside, because once it's vented to the outside, it starts behaving differently. It just vents. The one case where we run into that kind of an intersection with a floor, because I mean, typically the wall sits on the floor, but if you have like a high-rise with a glass curtain wall, and they tend to be aluminum and glass, which is not good, that joint becomes an issue because there's no Canadian tested fire stop system for that particular joint. So there's an American tested fire stop for that joint that we use typically, and I think there's reference in the 2020 National to that fire stop. But yeah, we're always writing alternative solutions too to build some kind of gypsum board and mineral wool box around that piece to protect that. Like we would build like a box around the bottom of that joint to protect the fire stop, because, well, in municipalities where they're on top of these things and they insist that we do. I think typically everybody else just uses the American fire stop. Oh, I love this picture. So in this municipality that shall remain unnamed, you also have to run the gypsum board on your fire separation before you butt any interior walls up against it. And these things are difficult to just do this sort of backing during framing, because especially here, I mean, it rains half the year without stopping, right? And it's going to be outside, and you got to get your drywaller in to do something before you're finished framing, and when does that ever happen? Every single 1 hour fire separation in the UL listings shows a detail for blocking where you're going to intersect your fire separation with an unrated partition. If it's a rated wall between suites butting into your corridor wall, all the better. But yeah, there's no, I mean, if we needed to run that board behind there probably wouldn't be 500 details in the ULC listings for not doing it. Okay, what time is it?
Thank you. Sorry.
Oh, well, we'll put the slides on our website. You don't have to write them all down. And the other purpose of the fire blocking, of course, is to separate vertical and horizontal concealed spaces from each other. Wall to floor, wall to roof, typically inherent in wood framing using the top plates. Drop ceilings and bulkheads at the, you all know all this stuff. And then typically looks like that. The code says if you run something through your fire block, you have to fill the gap with some material that will maintain the integrity of the fire block. The fire block being anything that'll sort of redirect fire in a different direction for 15 minutes. Oh yeah, so obviously the issue here is the top plate on the wall is, once everything's clad with gypsum board, the top plate's going to separate the vertical from the horizontal. Like that. But then when you do this, now the wall cavity is open to the ceiling cavity. And then this is what the code's trying to prevent. So we had a long, interesting discussion in the office about these slides the other day. It's like, can you do this? Because now is that bulkhead part of the floor? Or can you do this? And now that bulkhead's part of the wall? Or do you need to do both? I mean, that's typically what you see, right? Somebody drywalls the whole thing and then they build their bulkhead out of steel studs so they don't have to sprinkler anything inside it. But yeah, we had some interesting discussion on the previous two slides about whether you could do that. And maybe, depending on the size of the bulkhead, we thought, well, maybe if you use that 165 cubic meters out of NFPA 13, so you didn't have to sprinkler it, then maybe you could say. But I mean, it's going to be up to the individual, I guess, to decide whether that's an issue or not, or how big the space needs to be before you should do both. And one interesting thing about fire blocking now, so historically, the building code has always said that in an attic, you either sprinkler the attic or you fire block it into 300 square meter compartments with no dimension more than 20 meters. And in buildings, in the 6-story wood frame buildings in 32250 and 32258, now it says you have to do both, only in those buildings. So the items related to 6-story wood frame buildings, when it was only in the BC, they were all in 32250. And now in the national code, they're like spread all over hell. And then you're like, oh my God, I never noticed that one before. So there's a handout up here for if you want one after, that has every item related to 6-story wood frame buildings all in one table with the code references, and they're all there in one place, and you won't lose any. And this is a fire test of a fire stop system. So there's a few, we're just going to talk about joint fire stops for a minute, because I get this call all the time too. Do I need to fire caulk the joint between the wall and the ceiling? I'm like, well, not in wood framing. Don't you have like a whole bunch of wood behind there? So where we typically see that joint fire stop is between oddly shaped elements like the fluted steel floor and the steel stud and gypsum board wall, where the board's cut like this and you have a great big gap, or between dissimilar materials like gypsum board and concrete, where it's not perfect and you end up with a gap, or typically in steel stud, because you need that little gap. But the 2020 National Building Code definitely clarifies that you don't have to caulk the joints at the top and the bottom of a wall in wood frame because there's solid wood behind the joint. So fire stopping is about filling the holes. Of course, you know that. And the code says they're either sealed by a tested fire stop system, and that's a question all the time. Architects or somebody phones from the site and they go, do I have to put fire stop caulking here? And I was like, well, I don't know, what system are you using? You don't just buy a tube of FS1 and start squirting it all over the place. You have to look at the thing, and it says how big your annular space can be, or how, or what are you talking about? Or they're cast in place, which is easy, right? Concrete, there's no gap. Or they're tightly fitted, which I guess in the new section on outlet boxes, it kind of defines in there what it means by tightly fitted, for outlet boxes anyway. And there's two elements. There's the F rating, which is just spread of fire. And basically the mineral wool is the fire stop, and the caulking prevents smoke migration through it and sort of keeps everything in place. Unless you have one of those, like where you have a wire and you just use the Hilti intumescent stuff and the wire burns off and the stuff expands and closes the hole. And the T rating, which we need in a firewall, in a fire separation over a parkade that's been considered a separate building under 3212, and in this membrane-only ceiling thing, when we've butted the fire separations up to it. And the T rating is about temperature rise on the unexposed side of the assembly. So that's another thing that comes up in terms of myths with this membrane-only ceiling. When you think really, really hard about this thing, they say, oh, well, now only the membrane is the assembly. Therefore, now the temperature rise has to be measured at the top of the membrane and not at the top of the floor assembly. It's like, well, if you want to create a problem that can't be addressed by a fire stop system, I guess you could do that. But I don't think the fire doesn't behave differently based on whether or not you considered the joists when you looked at the fire resistance rating. And the fire stop in the gypsum board's only gonna last as long as it lasts, whether you counted the joists or not. So it doesn't, there isn't two different kinds of fire stops based on whether you looked at the whole assembly or you only looked at the ceiling membrane. Oh gosh, the outlet boxes. Anybody read the section on outlet boxes and fire stopping in the 2018? There's a couple of interesting things in there. There's a mistake, for one thing. It says you can waive the outlet box when it's tightly fitted. But it means you can waive the fire stop. And then there's information in the appendix about what might be an outlet box, which is quite helpful. So it talks about the typical, electrical box for your light fixture, junction boxes, switches, laundry, shower diverters. Those are some fairly large boxes, maybe the shower diverter. There's a handout on this too, because it's a little bit confusing. So it's not super clear in that section. It says, and I'm going to try to say it here. It says the tightly fitted thing applies to vertical fire separations and membranes on assemblies or forming part of an assembly that's required to have a fire resistance rating. So it's like, well, does that word vertical only apply to fire separations? Or does it mean all of it? So I know the 2018 interpretations are not on the website, but there's one that clarifies that it means all of it. So this stuff came out of the national code, and the national took it out of the international. And in that code, in the international code, it means all of it. So you can do the tightly fitted thing in the ceiling as well. So there's sort of three scenarios. There's combustible outlet boxes in any kind of fire separation, and it says they need the FT rated fire stop. There's non-combustible outlet boxes in that kind of, in an assembly, and it says there's a certain size and an aggregate area, kind of a density of them over a space, and that if the annular space between the membrane and the box isn't more, and the metal box isn't more than 3 millimeters, then that's tightly fitted and you don't have to fire stop it. And then in that membrane-only ceiling, you always have to have the FT-rated fire stop, even if it's metal. So then my next question, and I've been trying to figure this out since this came out in the 2015. I've talked to the national people and Hilti and everybody. It's like, where does that fire stop go? Does it go in the annular space? Or is it like some kind of putty pad or something that goes over the whole box? So it seems to me that if tightly fitting the box will fix the problem, so you don't need a fire stop, then the fire stop goes in the annular space around the box. And I've had a million conversations with Hilti, and Hilti says, there's no putty pad that would pass the T rating in a ceiling scenario. It will in a wall, but only because it's way down here. So there's an interpretation. Oh, that interpretation, sorry, that's the one I already talked about. But this seems to be what the building code says you need to do, that you need to fire stop the annular space around an outlet box with something that will limit temperature rise on the other side of the assembly, except for the fact that that's a metal outlet box or a plastic outlet box. I mean, there's a thing there that's going to transfer heat to the other side of the assembly. So why are we rating that? I don't know. Anyway, I believe this is on the province's radar, and they're going to maybe get it. It's also, I think it's on the 20 or the national code people's radar that there's some issues with this section. Yeah.
Has anybody attempted to address that, by putting a layer of
On the outlet boxes?
It says you have to limit the T rating. How do we do that?
Well, it seems to say you have to do it in the annular space. Doesn't seem to say that you have to do it behind the outlet box. It's a bit silly, really. What's the next? So this is an extreme method of dealing with the problem. Very labor intensive. This was a 6-story wood frame building, well, 2 of them actually, with a firewall in between them, so a huge building. And 2 layers of 5/8 type X behind every single outlet box in the whole building. The guy was banging boxes together for weeks.
Is that what exceeds when you said the maximum number of several?
Oh, close together. I don't know if it did. This was just a strictly a sort of belts and suspenders method of dealing with something that was in the code that it was pre-2018, but the building official called it anyway because they knew it was coming. That's a different conversation, that. Oh, this thing, it never works. It looks nice in the book, but the ceiling cavity is never deep enough to make that work somehow. So we do other things. We do this. Run the ceiling behind the duct so that the duct is inside the fire compartment. Or we do this. This is much easier to install. There is a couple of tested wall assemblies where they fastened this semi-rigid Roxel comfort board to the studs and fire tested it under the S101 test. And they got an hour out of a wall that had literally no gypsum board on it. All it had was studs and comfort board. So this stuff's, magic. Oh, the smoke dampers. So I spent the last week talking to mechanical engineers. They seem to be all kind of finding a method for not putting the smoke dampers. It's the code kind of says you need smoke dampers, and then it gives you a whole bunch of ways to not need smoke dampers. And they're getting kind of creative about it, I think. The one thing that I was trying to get to the bottom of was, it says a smoke damper has to be triggered by a smoke detector, which is a fire alarm device. And what if you don't have a fire alarm? Do you have to put in a smoke detector? Now you need a panel to run the smoke detector. Now it's got to be tested annually and maintained properly and everything. So you got some kind of piece of a fire alarm system in a building. Could you do it with an addressable alarm and a relay? I don't know. I asked 3 or 4 people, got 3 or 4 answers. So not entirely certain about what you would do if there wasn't a fire alarm system, because the code says that smoke damper has to be installed in accordance with the fire alarm standard in S524, which doesn't say what to do when there isn't a fire alarm. So don't have the answer to that, really, yet. I'm working on it. So the code prescribes now smoke dampers at ducts or transfer grills. So we spent a lot of time trying to figure out whether a duct on a grill was a duct or a transfer grill. And we decided that it was a duct, and a transfer grill is just a grill, just a hole in the... So you need it in a fire separation in a public corridor, or where you've measured the travel distance once in the suite and once in the corridor, which you could do that in an assembly occupancy where it wasn't actually a public corridor. And in group A, B, and C occupancies, and in these 2 protected zones that we have in the code, the one where you have an unsprinklered building and you don't have egress for people in wheelchairs, and you make a zone and then they move from one side to the other. Or the zone separation in a B occupancy where people don't evacuate the building, they move from one side to the other. So unless it is a duct and not a transfer grill for a kitchen exhaust, where all openings are in the same fire compartment, which, as we talked about before, a fire compartment is defined as being bounded by fire separations that have a fire resistance rating. So basically what that's saying is if all the openings are in the same fire compartment and your duct is passing through an unrated fire separation, then you don't need a smoke damper. Or it penetrates a fire separation between these protected zones and the air movement is continuous and the system won't recirculate air in a fire. Or it's a combustible duct for heating or cooling and the grills are down within 1,200 above the floor. Or it's a duct that goes into an exhaust riser that's under negative pressure and the air flows up. Or it's part of a smoke control system in a high building. So I thought about these things for a couple of weeks, and they basically fall into 3 categories, I think, where there's no potential for smoke to get into that duct and then be moved somewhere else in the building. So kitchen exhaust, obviously, just pulls it up and outside. Openings in the same fire compartment, because they're in the same fire compartment. The exhaust risers where the airflow is upward. Or where the air handling system doesn't shut down, right? So between these protected zones, for whatever reason, and it says if you have this and if the system doesn't shut off, and smoke control systems in high buildings. So now there's a sentence in 326 that says your corridor makeup air system in a high building can't shut down in a fire alarm, it has to stay on. So that means that the air never stops coming out of the duct. Therefore, the smoke's not going to go into the duct because the air is still coming out of the duct. But it also means that your corridor makeup air system has to be on your emergency power, which isn't a big deal in a high rise because you have a generator anyway. And then the third category seems to be these openings down closer to the floor. Oh gosh, we went too fast. It's okay? You must have questions. I have questions. No questions?
Start off with just a general one. What are the limits for T-bar ceilings?
You mean rated T-bar ceilings? I've seen one in 30 years, and the guy just about killed himself trying to put it in. Like, huh? They're very, very difficult to install properly, I think. Or maybe they're impossible. I don't know. I saw one person try it once in 30 years, and I've never seen anybody try it again. Do you have rated T-bar ceilings?
They're claiming they're rated T-bar ceilings.
Ooh.
I've seen a lot of rated T-bar ceilings on old drawings and in old buildings, and 30 years later, they were not rated at the beginning, and they're certainly not rated now. They've changed out, a whole bunch of it. 27 different.
Right. Can anybody hear what Dave's saying there? No. So, do you want a mic?
I've seen a lot of T-bar ceilings rated, for example, rated T-bar ceilings in old plans, in old buildings, and I do fire inspections, and not up to work. They do work when they were put in, but they sure don't work 30 years later when they've been modified 17 times. And it's a little bit there.
Yeah, I guess that's a sort of an issue too, right? Like, I mean, I know obviously if it's a rated, if you manage to figure out it's a rated ceiling when it goes in, somebody will change something down the road later and it won't be anymore. But I mean, you have no way of sort of managing things based on what might happen in the future, but.
So you're not familiar with any?
I'm not familiar with them.
System for T-bar ceilings.
No, we never see them, ever.
I think there's still only one that's approved.
There's only one that has a listing? I never even look at them on the UL listing thing.
Nobody will install them because they're so labor intensive and impossible to make a lot.
Right.
Clips in place, so.
Yeah, very difficult. I would look at that carefully. Right?
There's lots of fire resistant products out there, but they don't have a rating.
Yeah, there's lots of things that say they're lots of things, and then when you start looking into it, somebody sent me a rated outlet box, like a plastic outlet box with a fire resistance rating, 2 hours. I'm like, really? What's it made out of? And I started looking into it, and I think what they were saying was a 2-hour wall was tested with this outlet box in it, and it didn't impact the integrity of the wall. It's like, well, that's already permitted in the code without testing, so la-di-da. I don't think it's a 2-hour plastic outlet box. Anyway, somebody at the back had a hand. Oh,
Yeah, recently I had a small hardline short building with a public corridor. It wasn't built the way the architect designed it. And what do you have any general comments about mechanical systems running above those corridors and how they can be connected, especially close back spacing? You maybe aren't going to make one so off around the public corridor, and memory run all the surfaces above between them. I think other internationally, those may have some calculations for that, but I don't know that.
so if you have this membrane-only ceiling, and then your corridor walls and all your other walls abut up to it, then that's a common horizontal service space above it all. But those things are all passing through fire separations, like where you have outlets and, yeah, exactly. So the ceiling's a fire separation. Now you've got a bunch of holes in the fire separation. You have to see whether you meet there's criteria in Appendix D for the size and the spacing and the number, and it goes on and on for this long, and there's always one that doesn't work in the damn thing. Whether you have fire dampers and things everywhere, or you start doing those boxes around everything. That's tricky.
It's very tricky.
I saw a hand. Oh, you're just massaging your shoulder. Sorry.
Did you say that this material would be available on GHL's website, just with some handy pictures to reference?
Yeah. Yep. You want to just scoot forward? Oh, there it is. A copy of this presentation will be available at. There we go. If you want to write that down, we'll leave it there for a minute. Like there was a list, and we're going to back up a couple slides. There's a list of, when you're finished writing that down, if you want. Back again one. Okay, so there's some resources out there. So there's this ULC book. It's actually in my bag. Can you grab my bag? It's called The Criteria for Use and Extension of Data from Fire Endurance Tests. And it basically is this little book. Right there. It's this little book tells you everything you can change about a fire separation that was tested by ULC and not screw up the rating or the listing. So it kind of follows, you know, Harmathy's rules, of course, right? You can add things, you can't take them away, those kinds of things. You can make the studs bigger, you can put the studs closer together, you can do this, you can do that. Like somewhat practical, you know, discussion on, obviously you can't put the joists farther apart than they were in the test because now you don't have as many fasteners. But you can put them closer together because now you've got more fasteners, right? So I don't know if you can, if this is on, it's ancient. Well, not ancient. I mean, it's older than you. So it's from 1988. I don't know if that's older than you. Sorry? It's called the ULC Criteria for Use and Extension of Data from Fire Endurance Tests. It'll be on the... And then there's some structural fire protection by T.T. Lai. There's all those old NRC construction technology updates that go back decades. There's a Canadian Wood Council fire safety design in buildings. It doesn't really have a whole lot of stuff. And then there's this American thing I found that where they tested the engineered rim boards. That was quite interesting. Where is it? And there's the mid-rise wood frame construction handbook and the NRC best practices guide to fire blocking. That one's really good. And then there's the wood I-joist manufacturers have books about fire separations, tested details for those intersections and all that stuff. You need an early lunch? Oh, wait.
Back to that slide you had where you had the metal ducting and you lined the space with board.
Uh-huh.
What situation would you need to do that?
So if the duct was too big to be an opening in that membrane-only ceiling, because there's limits on size and density and everything. So if the duct is too big, then you basically run the fire separation behind it and it stays inside your suite.
Yeah.
Yeah. Yeah, I mean, if that, you're right, it is. I don't know exactly what that scenario might have been. The same concept as the boxes around the outlet boxes, right? That you're just running the fire separation behind them, and then you only have to worry about, fire stopping the wire instead of the whole. And I don't know if anybody wants to talk about pot lights. Oh my God. There's a sentence in the appendix that says the building code assumes a typical number, spacing, and concentration of openings in a fire separation that won't, compromise the fire separation. So what's typical? When they wrote the code, typical? I don't know, it was probably one light in the center of every room. It's not 35 pot lights in every suite. Pot lights they can be a problem because they can be big. There's always a lot of them, right? And they're made of aluminum, typically. So and then there was an appeal that said a pot light's not an outlet box. So recently, I think what we've been seeing more of is not the traditional metal pot. And there are some sort of intumescent hat things, right, that'll go over them, or people box around them, or we do alternative solutions, put mineral wool around them. But what we've been seeing more recently is like just those little LED things, and they just put them in an outlet box. So it's like, oh, now it's okay, now it's an outlet box. I don't know. It's probably okay if you have 6 or whatever. There's no guidance on it in the building code because they just never thought about having, 15 to 30 holes in every fire separation in every suite. Drop the ceiling, that's what I say. Holy cow. Yeah, pot lights are just frustrating for everybody.
In the one that you showed with the backing of where all these joint failures are, the horizontal vertical, anything within suite, right? So now you have to stack them. So you're continuously back there, and that's why the fire separation.
Yeah.
What happens when you run your res bar in there and now you have a gap?
Yeah, now you have a gap. Maybe,
It's not continuously back anymore.
right.
Can you repeat that, Frank?
So he said, so now the building code says, and we always have, that the joint that we're talking about is in the ceiling gypsum board to the wall gypsum board, and the new building code coming out says you don't have to fire stop that joint if it's backed by solid lumber. And he says, what if there's res bar on the ceiling, and now you've dropped that down, and maybe that joint isn't backed by the plate anymore? I guess what they'd say, if you don't have to fire stop it when it's backed, maybe that means you do have to fire stop it when it's not backed. But that's going to be weird to have fire stopping in here. I don't know. Does it drop it down enough that you're not on the plate anymore?
No, you're still on the top plate. You still got the top plate. But given the fact that that joint, especially on the single joint, is your failure. Right? Now you've got that single joint drop down a little bit, and you're only relying on that. So you have no backing.
Yeah.
If you have a piece of red board either way, that's
That ceiling drywall is still abut.
But it still abuts the top plate.
No gap there, it's just the gaps.
You've just moved the joint down a little bit.
Your your diagram showed a top, like that ceiling joint, plotted out against a.
Oh,
I would.
a vertical,
I
do
would never
you want to find it?
actually like your drawing.
It's way back there. Just look at yeah. It's the diagrams that you made. I don't think it matters. Yeah. Okay. Is it that, Dave?
No, you had another one where there was a top of fire separation.
It was before that. It was before that. Like, was it these? Oh, sorry. Hold on. Sure, look at that one. Was it these diagrams? Was it in the best practices guide? I don't know.
I just made a note of what you replied. Don't worry.
Okay. He said, never mind. We'll figure it out later. I'm doing it again at 3 o'clock. We'll figure it out before then. Okay. Any more questions? No? Okay. No questions. All done.